Hey guys, welcome back. We're just getting started here. We're going to answer question number 16. It says, take these vertices and rotate them 90 degrees across the origin. So I assume, since it just says 90, that I assume they're talking about counterclockwise. And so I need to make this pattern in my numbers. So X and Y switch spots and Y is negative. Okay, so going back to my assignment, X and Y switch spots. X and Y switch spots. And Y is negative. So that's my rule. Now let me double check I copied that down. X and Y, yeah, 90 degree clockwise, counterclockwise, is X and Y switch, and Y is negative. Okay, so back. All right, I can do that. So on my other piece of paper, just somewhere where I have room, 16, I can copy the coordinates. X and Y switch, so this one's here, this one's there. X and Y switch, and Y is negative. So this one that's been moved over here has changed signs. Cool. Now I'm going to rotate 270 from the origin. So looking at our notes, 270 has X and Y switch, and now X part is negative. The part that was X is now moved to the Y, but it's changed signs. Okay, so we write out our rule. X and Y flip, and the X part is negative. Okay, so let's find some space on a piece of paper or this paper and copy the coordinates. So they switch spots. And now I have to have this X part negative. So I change the sign of the coordinate that was X, and that's my new coordinate. Now, if I'm not sure, if I'm a little shaky, I can graph it, and then I can actually see that that is exactly where it moved to. All right, number 18 states, draw two lines of reflection so that the composition of the reflections across the line is equivalent to the rotation shown. So we learned any rotation can be expressed as a composition of reflections across two intersecting lines. So let's look at, here's my original shape. And I think if I flip it over this line, that's not looking good. This one's kind of a stumper. We didn't do practice problems like this. So let's see. So we have to flip it over two intersecting lines so that it would be equivalent to the rotation. I don't know. This is interesting. I guess I'll look at that one. All right, I'm going to go on to 19. If two lines intersect at a right angle at point P, so two lines intersect at a right angle at point P, what rotation is equivalent to the composition of the reflections across two lines? Oh, okay, so that's interesting. I think we noticed that the rotation is the same. 180-degree rotation is the same as reflecting off of both x and y. So we can kind of show that here. If I have a point, let's say I'm here at point -3, +2. If I reflect it over y, now I'm over here, right? So that's point +3, +2. Then if I reflect it again over the x-axis, I'm here at +3, -2. So I started here and I ended up there. Notice how I've swapped spots. It looks like this x and y are now in different locations. I've swapped, wait a minute. They swapped locations, but it's just their signs that are different now. You see this? The -3 is now +3, so it's changed signs, and the +2 is now a -2. Now let's see if that's equivalent to a rotation. Let's go look at our rules in our notes. So rotation, yeah, see this 180-degree counterclockwise or clockwise rotation takes my same coordinate and just changes the sign. So we learned here that the combination of reflecting across two lines that are 90 degrees from each other is going to be the equivalent of a rotation of 180 degrees. Cool. Okay. Let's keep going. So lesson 3.4 states, a glide reflection is a composition of a reflection and a translation. Any rigid motion could be any one of these four. As a result, the rigid motion could be expressed as a combination of each one and a combination of reflections. Pretty cool. So the example they give us is that this triangle could slide over here and then flip over this line to land there. So that would be a glide reflection. So they've told us first they reflect what would be an equivalent one that maps on top of there. So they're suggesting I could reflect across the x-axis, so I could change my colors here. I could reflect over here. And then scoot over. And it's like, oh yeah, we did that in class, where we figured out that sometimes order doesn't matter. We could do the reverse and we end up mapping on that same image. The red one maps onto the brown one, whether we go to the blue one first and then the brown, or the green one first and then the brown. All right, so let's take a look at our question number 20. Now, in some classes, we actually got a start on this question, so let's try it. We're being asked to move these vertices, right? And we got to make sure we do this one first. So I'm going to do this on graph paper. So check out the next video where I'll show you doing this on a piece of graph paper.